Welcome to Math in Bytes. Today we're going to be talking about logical statements. Let's start with the definition of a conditional statement. Conditional statement is a statement of if-then with a hypothesis and a conclusion. Symbolically, this is written as if P then Q. Let's give an example. If you are a dog, then you have 4 legs. In this case, our hypothesis, highlighted in red, is if you are a dog, and our conclusion is you have 4 legs. Now in math, we'd have an example like if 2x equals 4, then x equals 2. The converse of a conditional statement is the exchange of the hypothesis and the conclusion of the conditional statement. Symbolically, this is represented as if Q, then P. Now let's give an example. If you have 4 legs, then you are a dog. We switched the conclusion and the hypothesis from our first example. Now in this case, the converse is not true, because we can come up with a counter that something like cats have 4 legs. The inverse of a conditional statement is the negation of that conditional statement. Symbolically, this is written as not P, not Q. Let's give an example. If you are not a dog, then you do not have 4 legs. This again is a false statement. The contrapositive is the negation of the converse. Symbolically, this is represented as not Q, not P. An example is if you don't have 4 legs, then you are not a dog. Now, we can also come up with something called a biconditional statement. This is a 2-conditional statement including the conditional statement and its converse. Symbolically, it is P if and only if Q. Now, in order to make the statement, we need the conditional statement and its converse to be true. Let's give an example. Our conditional statement could be, if an animal has a neck over 4 feet, then it is a giraffe. The converse, by switching the hypothesis and the conclusion, we get, if it is a giraffe, then it has a neck over 4 feet. By combining these 2 statements to make our biconditional statement, we get, an animal has a neck over 4 feet if and only if it is a giraffe. Now, another example in terms of math is, 2 angles have the same measure if and only if they are congruent. Our conditional statement is, if 2 angles have the same measure, then they are congruent, and by switching these 2 conclusion and hypothesis, we get, if 2 angles are congruent, then they have the same measure. Now because both of these statements are true, we can come up with the biconditional statement that 2 angles have the same measure if and only if they're congruent. Now let's review everything that we've gone over. Today we went over conditional statements, the converse, inverse, contrapositive, and biconditional statements. Thanks for watching.